You're ready, right? It says live. Sorry? Okay. Hey, hello everyone. Sorry for this glitch. We've got multiple channels that is going on, and one of those channels is creating a problem. Welcome to GraphQL Architecture Masterclass. We'll kind of walk you through, in this particular series, a set of observations about how GraphQL and GraphQL APIs and APIs in general are built. And we have built a product that addresses some of the common issues that we have seen. And what we try to do in these master classes is to kind of walk you through the sets of problems and then show you a particular approach that we've taken at StepZen. So welcome again. This is the first of five talks. And today it's about how GraphQL can be built better and built quicker and run better. As a way of introducing ourselves, my name is Anand Chingran. I am the CEO for StepZen. And before StepZen, I was deeply involved in Apigee and at Google doing API stuff. And before that, as it dates me, we did a lot of stuff at IBM in the area of databases. Carlos, over to you.
Thank you, Anand. Hi, I'm Carlos Eberhardt. At StepZen, I work in customer success, so I'm primarily involved with working with customers and understanding their problems and coming up with strong solutions for them. Prior to StepZen, I've been with StepZen for about 2 years, and prior to that, I was with Apigee and then Google in similar roles. And going way back, I used to spend a lot of time sort of in the enterprise space with both really big, Fortune 100 companies and also very small ones. So I've got, I think, a nice perspective on some of the problems that users and developers run into when they're building solutions, whether it's a large enterprise situation or something small for a very specific application.
Yeah, Carlos, as people can see, we have a few gray hair, and that reflects
a little bit.
Absolutely. Okay, awesome. Okay, so what we'll do is, and we promise to keep it really, really tight. One is kind of our observation on why GraphQL at all. Why isn't what you have today good enough? What are the kind of current approaches in order to address building out GraphQL APIs? What are the challenges with those approaches? What's an alternative approach that, as you would guess, we're taking at StepZen? Carlos will do a demo to kind of bring out some of the highlights, and then Q&A, and then, of course, kind of an introduction to the next masterclass that we're going to do. Awesome. So the key question is, why do GraphQL at all? Right? So is it really, do you kind of view it as a better REST API? So we have, for example, as Carlos and I were mentioning, we have done REST APIs for over a decade, helping hundreds of customers through their API journey. And REST API is awesome, but clearly, GraphQL API enables the application developers, the users of the APIs, to actually ask for whatever bits they want. So in this particular case, somebody who's building a front-end e-commerce app, she might code in that when a customer is logged in, show me the name of the customer and the orders and everything else. And she gets all the bits that she really wants. So what we've seen is that GraphQL is really becoming very useful for app developers, and they're kind of putting a pressure on the backend teams, where some of you guys might be, to say, give us a good performant GraphQL API. So that's one reason why you might be doing GraphQL. A second, perhaps, an even broader kind of an architectural reason why you might do GraphQL is that GraphQL has this kind of superpower of being able to completely abstract away where the data is coming from. And your data is where your data is. It might sit in database systems. It might sit in enterprise apps. It might sit in SaaS apps. It might sit in the microservices that you built. Some of the microservices themselves may have been GraphQLized, or some of the backends might have been GraphQLized. But in the end, you're trying to provide an interface so that when an app developer comes in, he or she can actually get all the data they want, irrespective of where they are. So if you kind of turn your head towards the left-hand side, the app developer can ask for customer and order data, and they may very well come from two different systems, but the app developer, she doesn't actually care. So you've got to kind of figure out which way, what are the reasons for you to do it. Either reasons are good and great, but we believe that both of these reasons are fundamental drivers for why GraphQL is the right structure for the future of this kind of API slash data layer. And as you kind of think about these things, you also have to kind of figure out how much of abstraction and curation you want to do in your API tier. Typically, what we found in Apigee land was that APIs were used as a way of converting kind of backend exposure into front-end consumption. So you want to kind of do some curation in that API tier, but as you kind of think about curation, how much do you want to kind of tie to backends? So you've got three backends. Are you actually building an API that's a union of three, or an API that looks uniform irrespective of where the data is coming from? So those are some of the questions that you've got to kind of think through. And as we kind of go through it, you'll understand that we at StepZen have tried to build a product in support of these perspectives. So once you've decided to do GraphQL, hopefully all of you have, and some of you are thinking about it, you should. You've got kind of a choice of, I would say, kind of two ways of doing it. You can either start with code, and you can then kind of just get flexibility. I can code my way through everything else. Or you can start with these kind of low-code tools, and you can say that, look, let me point you to a backend, and out pops a GraphQL API. Okay, but those are kind of your two options that you have, and that's kind of typical what we saw, and one of the reasons why we actually started StepZen. So if you look at these two current approaches, the first approach is you write a code using OSS. You actually take GraphQL JS or its equivalent in your favorite language. I mean, your favorite language will be Kotlin, maybe Golang, maybe Rust, maybe Java, whatever else it is. And you take the GraphQL JS implementation, and you say, okay, let me kind of understand the concept of resolvers, and now let me kind of write code here. This is some Apollo JavaScript code, but doesn't really matter. You are in effect writing a set of resolvers and saying that when this piece of data element needs to be needed, you go and do this, and you're kind of writing code and more code and more code. The other option is you can do kind of GraphQL and X. You can start with a tool like Hasura or Figma and say, look, my data sits in a database typically, and can I get a GraphQL API? And you can kind of click your way through and kind of get your GraphQL API. So your two options typically are either roll your own on the left, or point against a specific backend and use a tool that is designed for that particular backend. The challenges with these two approaches, as you would guess, is that when you're writing your code, every bespoke backend is different. You go to it's kind of hard to understand and debug that kind of spaghetti code. It's repetitive code. You're doing the same thing for backend X, same thing for backend Y, and everything else. And then when you look at kind of GraphQL and X, whatever tool you pick, you typically find that those tools work very well against the database, but the REST APIs and XML APIs and the SOAP APIs are all very, very different. And so how do you kind of GraphQLize those in kind of a uniform fashion? And that's where you get kind of a friction between, look, I'm doing GraphQL on a database versus something that kind of is heterogeneous with respect to backends. And then a lot of these tools have kind of GUI built into it that you click, 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 and you get kind of a GraphQL API. That's super awesome from kind of getting started, but we actually strongly believe that GUI kind of gets in the way with respect to the CI/CD process and everything else. Okay, so with that, let me just kind of walk you through some even harder challenges that exist. So you've got the ability to kind of create your API with either writing code or kind of mashing up something with the database with something else with the REST API and everything else. But you get kind of an API out of either the left side or the right side. But there's a lot of hard stuff that really needs to be done in order for you to actually have a successful API program. Obviously, you need performance. What good is it assembling data from 3 or 4 different data sources, or even from one data source, if the wheel is spinning while you're collecting the data? It doesn't make sense. So how do you kind of optimize the query that comes in? How do you kind of insert the right caches? How do you kind of rewrite the queries to be able to combine stuff? And what we like to call is that the GraphQL API performant above and stingy below, so that your backend sources don't have to kind of scale up with the way that your GraphQL APIs need to scale up. How do you do early pruning, figure out whether you can go left or go right? You've got to figure out how to do deployments, get kind of really high availability. After all, this API sits between your applications, and your applications touch this API all the time. So it has to be 4 nines or 5 nines available. How do you scale it as this request goes up? How do you do geographical distribution? Obviously, with GraphQL API, you've got to worry about security. One of the reasons we have seen is a lot of people are somewhat skittish about GraphQL APIs because they feel that they don't fully understand kind of the security profiles associated with GraphQL APIs. And then in a subsequent masterclass, we'll show you that why you should not be worried about it. But you have to kind of think about authents and auths. How do you pass context? How are you doing the same thing across different backends? And obviously, no API is static, and it needs to evolve. Your team structure needs to evolve. You need to kind of break up one GraphQL API into a set of GraphQL APIs and federate across them. You've got to do change management and everything else. So the point really is that as much as you've got to kind of worry about how do you kind of get started and kind of connect against different backends, there's a lot of stuff below the waterline that you actually have got to worry about in order to make your GraphQL successful. And as you can guess, we have tried to make a lot of this to be really, really easy for you, your developers, and your architects and others that you all interact with. So to give you 2 examples of why below the waterline is hard, imagine a GraphQL query that kind of connects data that sits in the REST system, connects some kind of GraphQL API, connects some database system and GraphQL API. Just kind of an icon of a set of things that happen. And so when a request comes in, you've got to go to a REST call, you've got to make a GraphQL call, you've got to make a series of database calls, you've got to make a REST call, combine the results and everything else, and then try to figure out how to actually optimally execute this is not easy. And just to as one example of their optimal execution is, can you actually convert those 3 database calls, which are in these yellow circles, to actually be one database call and then kind of push down so the database can actually optimize it, right? So those are just examples of things that you've got to do in order to be able to have not just an API that works, but an API that performs. As kind of a second example of something that you've got to do is as I said, no API static, and you need to be able to kind of break up your API into different teams, and the teams need to combine. So how do you kind of take the code that you've done to actually build out an API and then kind of snip it in the middle and say, no, I'm going to now pass this piece of code to a different team, and then I'm going to federate over them, etc., etc. The question really is there kind of hard breaks? Can you actually build your federation model in the same way as you build your kind of uniform model? So these are just kind of 2 examples of things that as you think through, as you get excited about GraphQL, as you kind of build your first GraphQL, you've got to kind of think through and make happen. And again, as you guess, that's just something that we have tried to do, and hopefully you guys will agree, done a good job of with respect to some of these hard questions. So there's an alternative. The alternative is that we want to make it really, really easy against any backend. Okay, no backend in our mind is special. Yes, you may start with a database, or you may start with a REST call, or you may start with a SOAP call, but in the end, there is really no GraphQL API that doesn't kind of touch multiples of these. So we want to make it really simple against any backend, uniform against any backend. We believe that the developers and you want to kind of get kind of to close to a finish line very relatively easily, but yet you want some control. So the question is, can we actually enable you to not worry about some of the hard things and yet give you that 20% control? So what can we actually make it happen that is uniform across all backends? We do a lot of hard things that we don't want you to do, and yet you get kind of control. And that's what we've been doing at StepZen. Our inspiration in this is the world of databases. As I told you, I did, and many of us did databases at IBM. And in the world of databases, you let the database do kind of 80% of the magic. You create a table M with some fields, and you let the database figure out how you're going to lay it out when a query comes in on M, what to do, etc., etc. But the people who create the database or people who manage the database still get that kind of 20% control in order to be able to create stored procedures to do some programmatic access or create indexes to decide what to do, etc. So can you build a system in the GraphQL space where 80% of things are correctly and rightfully done for you, the hard things are done for you, and yet you can actually get that 20% of tweaking and magic. Okay, so in StepZen, the trick that we have is that we are able to kind of quickly GraphQLize any backend. It's just a starting point, and it doesn't matter what the backend is. We kind of look at it as one of 3 or 4 types, and we just kind of go in, introspect it, and build out its GraphQL layer. Then you as a developer, so that part is done by us, but then you as a developer can go and stitch those. You can modify it, you can curate it, you can change it, you can do everything. You got control in order to kind of make the curation of your API happen. The backend need not be exposed to the front end, so you can go and change it. You can connect the dots, and some magic can happen. And then in StepZen, then we kind of take care of a lot of hard things that I've talked about, that you don't have to worry about, the 80% hard things that you don't have to worry about, like optimization, protection, scaling, latency, deployment, caching, geo-distribution. And yet, we still want to give you some controls so that you can go and tweak it. So the idea really is make it really, really easy for you to get to the finish line fairly fast, and yet give you controls in order for you to actually then curate and do exactly the right things that need to be done. So with that, we'll switch to a demo, and we'll turn over to Carlos. Carlos, take it away.
Yeah, thank you. And actually, we don't really have a script for this, but I'm going to go off whatever script we have right now. And Anand, one thing that struck me when you were talking about sort of the analogy with the database world is that what we're doing is really possible because of sort of that advent of APIs in the world and SaaS solutions that have programmatic access that would enable you to kind of take that same database approach in terms of, the database decides how to store the data in file systems and things like that. Because without those APIs, we really couldn't do a lot of this, because the APIs are sort of like standard file system interfaces that the database had to work with. Does that make sense, Anand? Do you follow me what I'm getting?
In fact, at some of the point, you can actually show API creation out of file systems also, but we'll leave that for a separate.
Yeah. It just struck me, and I don't know why it hadn't struck me before, but when you were talking through that, I thought, hey, the reason this works is because of that explosion of APIs. So I think it's a natural evolution of sort of how we think about building systems and connecting systems together. So for a demo, I don't necessarily have something really scripted. What I wanted to do was walk through sort of what a project in StepZen looks like and what it looks like when you build a GraphQL API with StepZen, and to point out, I think, a few key things that sort of, rather than covering the gaps of other approaches, sort of bring together the best of those other approaches in terms of whether or not I'm writing something by hand and sort of really tuning things to work the way I want it to work, or whether I'm just saying, hey, I've got a database, make me an API in a hurry. So in this sample, we'll sort of look at how some of this was put together. And I'll hit a few key points. We're not going to go super deep. We've got a few other sessions coming up where we can dive into things like security and sort of more of the operations side of things. But in general, the way StepZen works is it's schema driven. So I'm essentially designing a schema, a GraphQL schema, and I'm giving StepZen some instructions about how to put that schema together and how to make all of that work. And one of the things that we do is we have an index file that allows me to refer to other files. And this makes it very nice if I want to do some organization. In this case, I did some very simple stuff in terms of organizing under domains, for lack of a better word. I've got a sales domain and a weather domain. In my sales, I've broken things up even further. I actually have 3 files here. I'm only referring to 2 of them. So we're only going to be deploying a GraphQL API that has types and queries. I've got my mutations pulled out separately, just for the sake of simplicity at this point. But when we go in and look at one of these, we can see that this is pretty much standard GraphQL schema. If you're familiar with it, I've got types and I've got fields on those types that they themselves have types. Everything's strongly typed. I do have a couple of little StepZen things in here that we can talk about a little bit later. This is essentially annotating a field saying, type customers has a field called contacts. Where does it get that data? This is how we're instructing StepZen to essentially resolve the request for that field. And this is a case where you would be in a code solution. I'd be writing a resolver to handle this request of contacts on the customer's field. Or if I'm using a tool, it may automatically make a connection for me like that. Or there may be a GUI where I go in and say, oh no, I want to pull this field in there and they're related this way. On the StepZen side, we're not doing any kind of that related stuff based on what the backend is. The relation is all driven by other attributes of the schema. So that's one way that we make that uniform approach, regardless of what's happening on the backend work, is that we use the schema itself to populate and resolve other types. But let's look at what a query looks like now. And in this case, we'll look at the customers one. This is a super simple one that was just generated automatically for me. The StepZen, when you work with StepZen, there's a CLI. And with the CLI, I can do things like I can import stuff. I can import a REST API through a curl command, or I can import a database by giving it some connection information. And we'll go and introspect what's in that database and populate some of this stuff. So you don't have to write it by hand. You don't need to do that. You could start and just write by hand. If you have a very simple API, it's really easy to just generate some schema by hand that solves a problem for you and gets up and going. But in this case, again, we're defining a field on our query called customers. And here's another StepZen directive called dbQuery that says essentially, when someone asks for that customers field, how do I resolve that field? I make a database call to Postgres. There's a configuration entry that's in my config YAML that has the connection string for the database, and you can customize how that works as well. But the schema itself is very simple in terms of where's the data come from and how do I get it. In this case, we just automatically will pull all the fields from customers. We can automatically do some querying as well, or if you wanted to customize how that's retrieved. And this is an example of going a bit beyond sort of the point and click approach, where I can write some custom SQL that would do something. And that could be something that executes a stored procedure to get the data, or does some common table expression stuff to build a much more complex query in terms of how it's retrieving that data. But it's very simple in terms of how you design it here. You're not worrying about connection pools. You're not worrying about some sort of an ORM that you're using. It's just tell the database what I want and I get the data back. And StepZen's GraphQL engine will then fit that response to the type that I've defined here. So in this case, I've got a few up and running. Let's deploy this quickly here. And we'll see how this runs. What the CLI is doing at this point is looking at the files I have in my directory, bundling them up. It's doing some validation to make sure that I don't have duplicate types, or I'm not trying to do something that's not going to work. And then it deploys it and it puts it to a URL here. And I've got a browser with that open. And let's just reload this so that we get the most current version of it. And I can come in and see that in my docs, I've got these queries that I've defined. So there's a countries, customers is in here somewhere. It's alphabetical, I'm sure. There's a customers, or I can get customer by ID, things like that. So very easily, let's ask for customer ID of, that's 5. And I can pull fields out of this, so I can get a name, say, and an address. And I can run this. And there I can see that I've got, this is just fake data. It's not real. So the names might be real, but they're not actual based on anything. And so it's very simple to do queries like that. And now I can manipulate sort of how that works if I come into my customer type. And I can do things. We can look at some of this stuff, contacts or orders. Let's grab orders. We can see if we request the orders field from this, I can then start to get details about orders. And I'll make that a little bit bigger. Order ID, order date, that sort of thing. So I've essentially, I'm not writing any code to link those two tables together. I don't have to write custom SQL to do that either. I can just do that by specifying that the resolver for this orders field defined in StepZen is simply a query that's also defined in StepZen, customer orders. And this customer orders query, if we take a look at it, takes a customer ID as an argument, and StepZen will automatically try to fulfill arguments for queries based on the fields that are in there, and I can customize that further if I need to do something like that. And so this query could be serving data from anything. In this case, it happens to be coming from the same database, but it could be coming from something
Carlos,
else.
just on that. So when it comes to the same database, we figure out. Remember that tree that I showed you with yellow nodes and blue nodes and others. We figure out that, look, even though the linking and structuring is happening in the GraphQL tier, connection between customers and orders happening GraphQL tier, in the end, they end up generating two queries to the same database, which have the same kind of configuration settings. So it's okay, can we combine both of them and actually make one query and get the results back, right? So those are kind of optimizations we do. We want to keep the GraphQL specification agnostic with respect to the backend, but at runtime, we try to do those kind of optimizations.
Okay. Yep, absolutely. Awesome. Great point. I should have brought that up. And that's just like, I don't know, I am not a database expert. So I'm always amazed when I throw really ugly queries at database systems. When I'm kind of learning how to do it, I select star from something and I start doing joins and all this stuff. And it's just ugly. And then if I look at the plan, I see that the database has said, oh no, yeah, the way you really should have written that was like this. Yeah. And here's how we're going to fetch the data.
It's called query rewrite. Okay. Can you show some REST call and see how that
let's take a look at a REST one. I've got a one that I've imported here, and I'm gonna modify this one so I've got some cheat stuff commented out. But essentially, this is pulling the weather for an address, and the way that this works, very similar to our DB query directive. We have a REST directive that takes more than what we see here. You can manipulate the payload and arguments and the HTTP method and authorization headers. You can do all the stuff you need to do to make a REST call. But in this case, all we really need to do is specify an endpoint, and we're passing in an argument on the path, and then we're providing an API key. And that API key, again, is coming from a configuration that I have saved. So now, once I have that there, I can then run a query over here, and I could ask for weather for address, and I could say that the address is.
You got curly brackets as opposed to round.
Thank you. I'll fix it.
Okay.
Good catch. This is the problem with the live kind of unscripted demo is typos. So I can pull out current conditions. That feels like we'll prettify that up. So we'll fire off two queries at once. And I can see that the conditions are clear and it's about 55 degrees or so. So now that's great. I can make a REST call. It works just the same way as a database call from the GraphQL side. As a consumer of this API, I don't even realize it. I don't know where that data is coming from. It could be coming from any number of systems. And then since I have an address here on customers, I ought to be able to basically take this address and feed it into my other query and see what the weather's like at that customer location. partially cloudy, a little bit warmer. Obviously, that's great that I've got that in the same API. But one of the nice things we want to be able to do is combine that and make that really nice. And the way we do that, very very much like we do with with pulling in another table, I'm just going to add a new field. I'm going to call it weather. And the name of the query is actually not customer weather, it's weather for address. One of the nice things about the way that this works, just being sort of schema in terms of building this out, is that you can use any editor that you like. I happen to like VS Code, but I've also been kind of a Golang fan before. Works the same way. It's not a big deal. And then you get all of that standard good developer editor capability with IntelliSense. We can set up, snippets to automatically do things for you. So it's really easy once you kind of get used to it to very quickly start making some changes. And I know that address here is a field available in customers, and it'll automatically get fed into that query. So if I redeploy this, now we also have a development mode. I'm using a little bit more of a disconnected mode where I'm just deploying in between, but there's a command called StepZen start, which fires up a little local proxy to that and will watch for changes, so you can kind of react to things very quickly live. This is a little bit nice for presenting, even though I do end up switching windows a little bit. So let's reload this to make sure we get the latest schema, and I'm going to get rid of that query, and I'm just going to say, and I don't care about orders right now. Let's just see what the weather is. And I can do kind of the same thing, and we'll run this query, and we'll see that I get the same result. So now that's one less thing that the developer needs to think about in terms of how they pull in data. It's available in the documentation that comes along automatically with GraphQL, so I can see that type is there. And I've eliminated a whole bunch of code that I don't need to write. So database access code is pretty much boilerplate. You kind of copy and paste and do the same thing. REST API code, a lot of time, is very, the HTTP part of it is absolutely the same every single time. You're only just tweaking a little bit about that. So we've gotten rid of a lot of that code. And at the same time, I've customized things so that I can make this act, however I really want to. I could change the name of this field. It doesn't matter. There's another type in here I wanted to show you if we look at, yeah.
So Carlos, I think people get the point, right?
Okay.
So awesome. So can we switch back to my presentation? Awesome. So what you saw was, I just want to make sure that everybody understands what you saw. You saw the fact that all backends are treated differently. Yes, in some backends you're doing a DB query call, in other backends you're doing a REST call. But the way you actually stitch things together, the way that somebody from the front end app consumes it, she's completely unaware of the backends that actually contribute to it. So if you kind of think a bit further out, if you switch from those backends to be from being kind of database backend or REST backends, but they've just become GraphQL backends, then you can actually federate GraphQL backends in exactly the same way as you'll stitch a database with a database or within a database or database across REST and everything else. So that's point number one. Point number two is that we've got a lot of helper tools. What Carlos showed you was actually code that you'd say, that's a lot of code to write. But the schema is what the schema is, and you write exactly the schema. But we've got this kind of helper tools which kind of look at the back end, and you can do a StepZen import database or StepZen import curl, and you get all of that code kind of written up for you, and then you can go and modify and make those things happen. And the third thing is that I want to just again make sure that the elegance of schema and stitching in schema with this kind of declarative way, which means you are really connecting at kind of query level and data level, does not necessarily mean that your performance suffers. We try to figure out and make all the kind of optimization things that happen in that. So thank you very much, Carlos. I know there's a lot to show, but you've got 4 other master classes, so hold your horses so that we can kind of talk about many of those also.
Yeah, we just skimmed the surface there. There's a lot of really fun customization that you can do beyond kind of that simple stuff that takes just as much effort as what you saw. It's usually one line to make some really fun things happen in terms of how you're designing that API. And I do think one thing I wanted to say that I forgot to mention is that just kind of being an old API guy, I do think that the design and the user experience matters. And that's one of the things that I think that I really liked about the code approach is that you can make it look and work exactly the way you want it to work, or exactly the way your customers expect it to work, without concern for, you know, someone else's opinion about how it should work. And that's one of the things I like about StepZen, is that you can do the same thing here, but you don't have to write all the code. We did have one quick question that I wanted to get before we forgot it. Akila had asked if we had code extensions for the color highlighting and things like that in VS Code. And we don't have a specific StepZen one, but I am using one called GraphQL syntax highlighting that works really well. It understands that there can be custom directives, so it doesn't flag those as being, you know, a problem with the schema, but it will also help you do kind of just the catch the obvious mistakes as you're typing that in there. So it's called GraphQL syntax highlighting in the extensions library.
Awesome, fantastic. Okay, so obviously there's here are some of the resources, and these resources will be available anyway. Why we think GraphQL is that superpower with respect to better access, what is it that we believe about with respect to kind of optimization, and obviously some of the connections to kind of getting started. Okay, so Carlos already answered a question on kind of GraphQL syntax highlighting. Do we have other questions, folks? Okay, awesome. I'm hearing some music in the background. It sounds like maybe it's at my end, but we'll wait for one more minute. Hey, Carlos. So in what you showed, how much of the kind of the code that was generated, okay, versus how much of the code that you kind of modified? What is the best practice with respect to kind of creating a gap between how backends view the data and how front ends want to consume the data?
Sure, that's a great question, and I can talk a little bit about how I kind of started putting that together, I think, when I answer it. With the database has I forget how many, a dozen or 24 tables in it with foreign key relationships between everything. And not all of those are something that I would want to put into my API. For example, I may not. GraphQL, one of the concerns people have is that once you have that graph built, people can start to traverse it in any kind of direction. And one of the things that I think makes curation important is that you can kind of control that. Now, it may make sense in some cases to allow that path travel in every which way, but for specific applications, for example, if you're doing sort of a back end for front end pattern, you want to make sure that you're restricting how that graph is used, just from a security perspective and a performance perspective. So in this case, I asked StepZen to import that database, and I asked it to create relationships for every foreign key it found. So it did that. It created a whole bunch of those things. So customers have contacts, and contacts have customers, and orders, and all of that stuff was related. And then what I went in to do was essentially prune that. I went in with the mind of thinking about having a use in mind for this, and saying, okay, well, really what we're going, if we were doing something like a customer support or a customer service application, I'm probably starting at the top level of customer. So I made sure that my relationships could all be driven from that. And then I built out and essentially pruned out capabilities that StepZen had found and added. I said, no, I don't want that. So I started curating my API. And then I changed the names of a few different things, because I don't, no offense to database people, but sometimes they pick odd names for columns, and I wanted them to be a little bit more user friendly. So I did a little bit of work there to clean that up. And similarly with the REST API, REST is often it's a little bit more of a manual effort to get that really working the way you want compared to a database. Database import's pretty quick. REST is, because each method can generate different types and things like that, you kind of need to iterate a little bit more, but a very similar process. I wanted to make sure that there was only a single way to get at the data that was in there, so I curated that a little bit more as well. And it's really nice when you have a schema-driven approach to this, because I could have a table, a really large table of customer information, but the application that I'm building this for, again, in the thinking about, is this from sort of a back end for front end approach, only is concerned with half the fields. So I just dump those entirely from the schema. I don't need to worry about it. Obviously, if I'm building more of an enterprise graph where I've got all the data available, I'm probably not going to curate it that way. I'm going to do it a little bit different. I'm going to think about from a microservices domain perspective and enable a lot more capability for people.
Awesome, fantastic. And then again, in both those cases, we want to make sure that if you want to start from scratch, you can start from scratch. But if you don't want to start from scratch, you've got awesome import capabilities that will actually give you something that's a starting point. Okay, awesome. There's a question here on they haven't found anything about subscription in StepZen. That's absolutely right. StepZen doesn't currently support subscription. We are working at it, and it's a matter of weeks when it will be there. But meanwhile, if you guys want to talk about how some of our customers are actually doing subscription by using webhooks and repeated queries and all that stuff, we'll be very happy to tell you, talk to you about it, talk to Carlos about it. But subscription is a feature that would be coming very soon.
One of the interesting things about subscriptions, and I think one of the reasons it made sense to not do them at first, is if you think about how you're going to actually implement that from the back end perspective, it's gonna vary based on the capabilities of the back end. So if you take that StepZen view of everything should be uniform from the GraphQL front side perspective, we need to get to sort of a bare minimum of how are we going to handle this securely and scalably, if that's a word, in a manner that performs well, when the backend might be a database, or it might be a GraphQL API that already supports subscriptions, or it might be a REST API that doesn't have a webhook capability. There's a lot of variety in terms of the things you need to worry about from an operations perspective, less about how the actual API works on the front side, because that's going to just be that subscription method. But what kind of controls do we need to provide for someone who's connecting up a REST API versus a database, so that that they can make that subscription perform well?
That's an awesome point.
That's almost here, so I'm excited to see that.
It's awesome, but the point is really that while if you go back to GraphQL and X, some of us run databases and we love databases, but we think that the future of GraphQL is not GraphQL just on databases. And subscription solutions out there that work well with databases or purportedly work well with databases are interesting, but in our worldview, don't represent a majority of the use cases, and that subscription has to work across all the backends. So that's why we've been kind of being slightly deliberative about it and doing the right things. But Elias will be kind of unveiling it fairly soon. Okay, awesome. So hopefully you guys like what you saw. There are many things coming, and the next one is on security. As I said, we find a lot of people are skittish about GraphQL, saying, I don't know what data can get exposed and everything else. And Carlos and I will kind of walk you through what are some of the common issues that we've seen, and obviously kind of our opinionated way on how they should solve it. So we hope that you will join, and then you will have your colleagues and your friends and others also join us. So with that, thank you very much, and have a great day.
Thanks, Al.